All right, so um, welcome to an inorganic tutor lesson. All right, today we want to look at this economic question, how to go about it. If you have this question, how to navigate your way out and then come out successfully. All right, but before I begin, I want to say shout out to Mr. Rad and then Mr. Ada Enoch, as well as my cameraman Konab Isa. Big ups. So, how do you go about this question if you are given this question in an exam or in a quiz or any field that you find yourself? Let's go. A palm oil producing company has the following variable cost function. All right. So this is a variable cost function. Total variable cost function is equal to 200 kilo minus 9 kilo squared plus 0.25. Alright, and they said if the company's fixed costs are equal to 150 Ghana cedis, alright, find out the total cost, marginal cost function, average variable cost function, average total cost function. Find the level of output at which average cost and marginal cost is at its minimum. All right. So let's look at how we can navigate our way out to solve this question successfully. All right. Now we know that total cost is equal to total fixed cost plus total variable cost. All right. And now we have been given total variable cost, and then we have been given total fixed cost as well. All right. So getting the total cost, we say total cost is equal to 150 plus the total variable cost, which is 200 kilo minus 9 kilo squared plus 0.25 kilo cube. All right. So this becomes our total cost function as demanded in the question. All right. So having the total variable cost and the total fixed cost, and you are asked to find the total cost function, all you do is that you state your formula. All right, as total cost function is equal to total fixed cost plus your total variable cost. All right. So after that, you just fix in or plug in your values for the total variable cost and the total fixed cost. All right. So that is very simple for the total cost function. So let's look at the marginal cost function. You already know that if you have your total cost function and you want to derive your marginal cost function, all we do is that, or what the rule states is that we differentiate the total cost function with respect to the output that we are having in the function. All right. So our marginal cost function MC is equal to the differential of the total cost over the differential of the quantity. All right. So differentiate the total cost function with respect to the quantity or the output. All right. So here we have the total cost function now is 150 plus. So differentiating the total cost function, you can say d of the total cost function 150 plus 200 kilo minus 9 kilos squared plus 0.25 kilo cube the cube. All right. So from here we can see that our marginal cost function is given as the differential of the total cost function, and this gives us 200 minus differentiate 150. You know that differentiating the constant to give you 0. All right. And then you differentiate 200, and then you get you get differentiate 200q, and then you get 200, because differentiate to 200q, you subtract 1 from the exponent, then when you use the exponent to multiply the 200, then you subtract 1 from there. So 1 minus 1 will give you what? 0. Alright, so differentiate to 200q, we get 200 minus the differential of 9q squared. So we have 18q. Alright, plus 0.75q squared. Alright, so that is for the marginal cost function derived. Alright, so that is very easy for you to get the marginal cost function whilst you are having the total cost function. It's very easy arriving at your solution. Alright, so let's look at the next part of the question, which states that we should find the average variable cost function. Alright, finding the average variable cost function, we know that finding the average variable cost function, we know that we have the total variable cost. So getting the average variable cost, we just divide by the quantity, then we obtain our average variable cost function. All right, so it's very easy navigating your way out on how to find the average variable cost function. All right, so from here we say that average variable cost function is equal to TVC over Q. Very easy. So you have your TVC, that is the total variable cost function, given in the question. So we have 200q minus 9q squared plus 0.25 q over q. All right, so our average variable cost is equal to 200q minus 9q squared plus 0.25 q over q gives us 200 minus 9q plus 0.25 q squared. All right, so this is very easy navigating your way out. Don't just chew what we call chew the formulas. It's just about deriving them by yourself. All right, very easy. So let's go to the next part. They said we should find the average total cost function. Find the average total cost function, and we know that finding the average total cost function, the average total cost function, that is the ATC, and we know that our ATC is equal to TC over Q. All right, so ATC is equal to TC over Q. So we have, as usual, ATC is equal to TC, whereas we have our TC as 150 plus 200q minus 9q squared plus 0.25 q over q squared over q. All right, so ATC is now giving us 150 q to the power minus 1 plus 200 minus 9q plus 0.25 q squared. So this becomes our average total cost function. All right, it's very easy, just a matter of you understanding the question. Understanding the question is part of your quizzes or your exams as well. So that is basically the answer for the D, the average total cost. All right, so let's continue with the last part of the question says we should find the level of output at which average cost will be at its minimum. All right. So hearing this question, what you have to know, or what you must know, is that if you want to find the average cost, or the average cost, or the average cost at which the output is at its minimum, then we differentiate the average cost. All right, we differentiate the average cost and then equate it to 0. All right, when you equate it to 0, then you'll be getting a simple equation and solve for your output. All right, so let's do that. So he said average variable cost at its minimum. So we differentiate the average variable cost so ABC is at its minimum. Or will be at its minimum if the differential of ABC with respect to the quantity is equal to 0. All right, so we say the differential of the ABC function, whereas we had 200 minus 9q plus 0.25 q squared. When you differentiate this, you should get 0. All right, so we differentiate this, we get minus 9 plus 0.5 q should be equal to 0. All right, so from here we solve for the output, which is the q, and say 0.5 should be equal to 9. So our output is going to be 9 over 0.5, and that will give us 18 units. All right, so this is the level of output at which ABC is at its minimum. So we conclude by saying, hence, the level of output at which ABC is at its minimum is 18 units. All right, so that's basically the solution to the D. And they also said we should find the marginal cost at its minimum. All right, the marginal cost at its minimum. And so the next part of the question will be the differential of MC with respect to the quantity. So we differentiate the MC function, which we obtained as 200 minus 18 kilo plus 0.25 75 kilo squared. All right, so we differentiate this and it must be equal to 0. All right, so differentiate this, equate it to 0, solve for the quantity, and the output you obtain, that will be the level of output that will minimize the company's production. All right, so we say differentiate this, we get minus 18 plus 1.5 Q should be equal to 0. So we say 1.5 Q is equal to 18. So our Q is equal to 18 divided by 1.5. You say 12 units. All right. So this is the level of output at which the marginal cost function is at its minimum. All right. So we conclude by saying, hence, the level of output at which MC is at its minimum is 12 units. Right. So this is very, very easy to navigate your way out when you are given such a problem. All right. All I want you to know is that the functions, the formulas, you don't need to, chew them. But then when you are given the function, you know that when you want to find the average of something, it's always over the quantity. All right. So having the total cost function, all right, and you want to find the average total cost function, just differentiate, just divide by the quantity, and then you obtain the average total cost function. All right, and then having the total cost function and you want to obtain the marginal cost function, what we do is that, or what you're supposed to do is that you differentiate the total cost function and then you arrive at the marginal cost function. However, function, if you have the marginal cost function and you want to derive the total cost function, you integrate. All right, you integrate the marginal cost function and then you arrive at the total cost function. So with that, you'll be having a constant of integration, and that constant of integration will represent your total variable, your total fixed cost. All right. So get it very clear, very, very clear. If you differentiate the total cost function, you obtain your marginal cost function, and having the marginal cost function, wanting to find the total cost function, you integrate your marginal cost function and then plus a constant of integration, whereas that constant of integration is going to be your total fixed cost. All right, and then you do your substitution or plug in your values, then you obtain your total cost function. All right, very, very simple. And then what you must also know is that TC is equal to average cost. That is, the total cost is equal to the average cost times the quantity. So if you have the average cost function and you want the total cost function, all you do is that you divide your total cost function by the quantity. All right, then you obtain your average cost function. So very, very easy to navigate your way out in how to go about this type of questions in economics. All right, Thank you very much for watching, for having such a wonderful lesson. Thank you very much.